Shake Table Lab by Will Cummins and Isaac Kim. Following Will and I holding our design, we have a diagram that I drew before I started crafting our building. Our first story is 18 centimeters in height, as well as the second one, because the minimum height for our building was 36 centimeters. As you can see, this is our construction number 1. We were building our tower and this is the base of our building. Subsequent to our construction number 1, construction number 2 provides information about our shake table tower. We're almost finished in constructing our base. Then, you can see that it is our construction number 3. We're done with our base and moving on to decorating our roof. After construction number 3 is construction number 4. Construction number 4 is the finished version of our tower. We pasted construction paper on both sides and not on the top since we thought that this would be better to look at. This is the total height of our building. The total height of our building is 71.12 centimeters. The first story has a height of 20.32 centimeters. The second story has a height of 21.59 centimeters. And the third story has a height of 26.67 centimeters. As you can see, this is our building and it holds two 250-gram sandbags on each floor. This is static testing. I introduce you to our strengthening part in our building. Will and I thought that if we put a cross on each side of our building, that would fortify our shake table lab project. We have the strengthening part in our building. Will and I thought that if we put a cross around the building, that will fortify our shake table project. Also, if we put a tape around the cross, that will secure our crosses too. There are no doubts that our strongest part had to be our cross. It is the heart of our building because it supports our building so much. Since we talked about the tower's strongest part, let's talk about the weakest part. We agreed that the weakest part in our building was the bottom of our second story. The reason was because we put the straws a little bit excessively so that it created a bump. Subsequent to our weakest part, I present to you the taping part in our tower. Well, this is the part where, in my opinion, has the most tape, so the title for this is taping. Lastly, this is the extra supplies flooring part. We were limited to a specific amount of straws, but then Mr. C was really generous, so we got more straws. With this last straws, we started to floor our building and make the crosses. Every time our building supported the amount of sandbags increased, and this is our building supporting 12 and 16 sandbags.
Oh no, it's like flexing a lot now. Wait, that's so strange. That those two, they're like oh god.
Wait, this one has no center supports.
I know.
Yeah.
How is it lasting so long? Well, the center supports.
In total, our building supported 16 sandbags and filled at the last second on 18 sandbags.
There's no way.
Oh wow.
Oh wow. Fall.
Don't fall.
The x-axis in the graph represents the side-to-side motion. The y-axis in the graph represents forward and backward motion. And our z-axis shows how much our tower moved up and down. This is my interview. My name is Isaac Kim, and my Shake Table Lab partner was Will Cummins. Our building supported 16 sandbags, and when it was 14 sandbags, our buildings flexed a lot and the straws began to bend. The place where our building failed was the first floor, and the reason was because we didn't add the center beams and we added too much straws at the bottom. And if we could change one thing, then I would have added the cross beams so that it could support more weight. And if what I learned about the earthquake-proof building is that we need a skeleton inside the building so that it could support the building more and better. And lastly, I enjoyed the Shake Table Lab project because I like cooperating with my partner and I like to see our building fall. Thank you. This is my partner Will Kuman's interview.
I'm Will Cummins, and our tower supported 16 250 gram sandbags. And after 12 sandbags, it was pretty obvious that the tower was going to go down soon because the straws were beginning to flex. And our building failed because the first floor, the cross beams were beginning to bend and there wasn't enough support to hold up all of the weight. Isaac and I could have put some center supports in the middle of the tower so it could support some of the weight also and not have all the cross beams do all the work. And I learned that if you want to build an earthquake-proof tower, you have to have like the skeleton of the building inside, so it's not just cement and there's something to hold up the building. And I enjoyed this project because I like to see how the tower got stronger when we strengthened it and added more straws. I like to see how it got stronger as we went, and I liked working together with my partner Isaac. Thank you.